This lesson is for section 6.10. We're going to be working on properties of logs. And we have three main objectives for today. One is to use the properties of logs to expand and condense expressions, and then also to evaluate expressions. Our last objective for the day is actually more so tied to tomorrow, but I want to see if you're going to be able to solve logarithmic equations based off of your rules that you're learning today. So whether you're dealing with exponents or log expressions, you want to make sure that you're following these three golden rules, okay? Now, we're going over these together because I want you to see how closely related they actually are. Now, we've already worked with these rules here extensively in Chapter 6, so these should come back to you very quickly. And I want you to see how they are closely related to the properties of logarithms and the rules that you should be following when you simplify a logarithmic expression. So starting with the product of powers, we know that when we have exponents with the exact same base, we simply add our exponents. So this becomes x to the a plus b. Now, when we deal with logs and we take the log of a product, so here we have a product, it's the log of a times b, we can split up this log and add them, or make them the sum of two logs. So we can call this log base x of a plus log base x of b. Okay, so we're using the same base, and we're just splitting up our arguments into a and b separately, but log base x of a plus log base x of b. Now, when you look at a quotient of powers, you have the same base, right, for both of these. You can simply subtract your exponents. Now, when you deal with the log of a quotient, now I have log base x of a over b, right, it's a quotient here. I can separate these logs and write them as two different logs, and write this as the difference of log base x of a minus log base x of b. Finally, the power of a power. So I have x to the a raised to the b power. I make that the product of a times b. So that's x raised to the a times b. Now the log of a power is similar to, you're going to be creating a product here, but basically we have this log base x of a raised to this power of b. You're going to take b and place it out in front and create a product here. So this is equivalent to b times log base x of a. So a lot of times I'll just write that without the little multiplication symbol. So this is assumed that you realize that there's a product here, b times this expression for log base x of a. Okay, so those are our three golden rules. So now let's use those rules to try to evaluate some of the problems below. This is one of our objectives, is just for you to be able to evaluate using your properties for logs. So let's begin by evaluating problems 1 through 6 here. So this is one of our main objectives. Now this is a pretty difficult section. I think actually this is probably the most difficult part of what you're going to be doing from this particular lesson. So if you're confused at all, you could replay it, of course, or ask questions in class tomorrow, but don't get discouraged if this doesn't come very naturally or easily to you, because the more you practice with your properties, the better off you'll be at trying to evaluate when you're given some information like you are in these problems. So basically we're given a series of statements. We have log base b of 2 is equal to a, log base b of 5 is equal to b, and log base b of 7 is equal to c. Notice that there are no actual numbers here. You're given everything in terms of variables, and that's okay. We're still going to try to simplify though and evaluate this expression. So what your goal is to use your properties that you learned above and try to manipulate this expression so that you can contain and rewrite it using any of these, so that you can use substitution and use those statements to further simplify. So let's get started. Log base b of the fifth root of 0.4. Now I'm going to rewrite this argument so that I can try to include some of these numbers above here. Now I look at the fifth root of 0.4 and I can rewrite that as the log base b of 4/10, right? 0.4 is 4/10 raised to the 1/5 power. Now that I've created something with a power in it, I can use that third rule that we talked about, where we take that power and we write it out in front. Okay, so now I have 1/5 times log base b of 4/10. Okay, so I've simplified it a little bit more, and when I look at 4/10, I know that I can simplify that fraction, so now I end up with 2/5. So this is good because I see I have a 2 here. I also have a 5 here. So somehow I want to try to include log base b of 2 and log base b of 5. And I can do that because I have a quotient. So now I'm going to apply that second rule we talked about, where we take a quotient and we make that into two separate logs, and it's the difference of those two logs. So remember, we're taking 1/5 times this whole thing, right? This is one expression. So when I write and try to expand this here, I'm going to write that as 1/5 times, in parentheses, log base b of 2 minus log base b of 5. After that, now I've actually rewritten, my goal here is to rewrite that in terms of log base b of 2. So now I can use substitution here and write that as 1/5 times log base b of 2 is equal to a. So I'm just going to write that as a. And the log base b of 5 is equal to b. So I take that and I write that as minus b. Whoops, didn't mean to switch colors so many times. Let's do it in red. So minus b. Okay. So log base b of the 5th root of 0.4 is equal to 1/5 times big A minus b, big B. And that's how you are going to simplify, and that's as far as you can go actually, because you don't have values for A and B. So that's our first example, and I know it's probably a little confusing. The more you apply these properties though, I think the better off you're going to be. So let's continue and go to problem 2. So let me erase here and go to 2. Alright, in problem 2, we're asked to find log base b of 7/16. Now right away I recognize this as a quotient, so I want to separate this in two separate logs. Write it as the difference of the log base b of 7 minus the log base b of 16. Now already I recognize that I already have a value for log base b of 7 that's going to equal c, so I actually don't have to simplify this any further. I'm going to leave it like it is. Now the log base b of 16 doesn't have, it's not 2 and it's not 5 yet, but I can rewrite 16. Okay, so we always want to think in terms of trying to rewrite something. Now 16 is 2 to the 5th power. Oh, sorry, 4th, what am I saying? 2 to the 4th power. Okay, so we have log base b of 7 minus log base b of 2 to the 4th power. These are equivalent to each other. Now that I have a power here, I can bring that power out in front of this log. So this is the same as the log base b of 7 minus 4 times the log base b of 2. And now that I have just log base b of 2, I'm going to use substitution here. So let's substitute both of these values in. Log base b of 7 is equal to c, big C, so I have c minus 4 times the log base b of 2, which was big A. So this example here simplifies to c minus 4a. Alright, next up, number 3. Log base b of 3.5. Now this is just one number, 3.5. So what you have to do is try to think of how you can manipulate 3.5 and rewrite it in an alternate form. Now 3.5 is the same as 7/2. So this is the log base b of 7/2. This is now something that I can rewrite as the difference of two logs. So log base b of 7 minus log base b of 2. And because I already have log base b of 7 and log base b of 2 defined, remember these I can just substitute in as c minus a. Alright, so I think that this is tough, again, because you have to manipulate so many things and kind of think outside the box. But again, the more practice you have with it, the better off you're going to be. Okay, now in our next set of examples here, our given is a little bit different. Here we're asked to evaluate these logs, and we're not supposed to do it with a calculator. We're supposed to do it based off of the given that they tell us that log base 3 is approximately 0.477 and log base 10 of 7 is equal to, or approximately 0.845. So both of these are base 10, and everything else here is base 10 as well. But what our goal is to be able to rewrite this in terms of these two logs. Now the log of 21 can be written as the product of 3 and 7. So the log of 21 I'm going to rewrite as log of 3 times 7. So when I split this up, I know that I can use my first rule that we talked about, where I say log of 3 plus the log of 7. And now that I know that log base 3 or log base 10 of 3 is approximately 0.477, I'm going to approximate this as 0.477 plus this value is approximately 0.845. Right, log of 7 is approximately 0.845, and then I'm just going to add these values together. So This is something you're doing without a calculator. You'll do this on a quiz and a test too, so make sure that you're comfortable with, adding 3-digit numbers. So 7 plus 5 is 12, carry the 1. 11 plus 1 is 12, carry the 1, you get 13. So I'm going to put my decimal between 1 and 3 here. So this is 1.322. So this is approximately 1.322. Now this is probably a good place for me to show you somewhere where people make errors. So right away here, I will have students who write that as log of 3 times log of 7. This is not following our rule at all though, okay? So our rule says that if you take a product, then you can split it up into 2 different logs. So the first thing we have to do is to make sure that we write it in terms of what the product is first, then you need to split it up, okay? So don't interpret it like this. This would be very, very bad. It's not actually using the correct rule then. So even though it seems redundant, just write this in. It usually helps if you write that step in. Usually I don't have students who make mistakes if they show the work here, instead of skipping straight to here, okay? All right, the next question here, number 5, this was pretty easy because it's, I think, laid out there for you nicely. So we have log of 7/3. So this is a quotient. I'm going to rewrite that as log of 7 minus log of 3. So now I'm taking the value, because I'm approximating this to be 0.845 minus 0.477. I'll let you guys evaluate that one if you want to get that practice, and then check with the key. Okay, number 6 here. We have the log of 343. Now I know that I have a value for 3 and for 7, right? Log of 3 and log of 7. So I want to try to rewrite this so that I have a 3 or 7 appearing. Now if I take 7 to the 3rd power, I would get 343. So this could be rewritten as log 7 to the 3rd power. Now that I have this written with a power here, I'm going to bring this power out in front, so I have 3 times the log of 7. Now this is approximately 3 times, remember log of 7 is 0.845, so now I'm multiplying 3 times 0.845. Now when you do this, it's probably easiest to take 845 and then just multiply it by 3. So you're going to take 15, carry the 1, so carry the 1 again, and you have 25,035. Now we have 3 decimal places that we need to move though, so that would be 2.535. So this is approximately 2.535. The next type of problems that you'll be asked to do from this section is to expand and simplify using your log properties. So we're just going to keep practicing using our properties. Now here I have log base 9 of y over 729. If I want to rewrite this, this would be log base 9 of y minus log base 9 of 729. Now normally we'd be finished here, but because 729 is a power of 9, I'm going to rewrite that as log base 9 of y minus log base 9 of 9 to the 3rd power. Now I'm going to bring that 3 out in front, so I have log base 9 of y minus 3 times the log base 9 of 9. Okay, now this, right, log base 9 of 9 is equal to 1, so this is log base 9 of y minus just 3. So this is us expanding and then simplifying this expression as much as we can. Let's look at number 8 now. Okay, for number 8 we have the log base 2 of 4 plus the log base 2 of x. So I take that product and I can split that up into 2 separate logs with the same base. Now here I can rewrite that. You can evaluate this. If you wanted to write this as log base 2 of 2 squared and bring that 2 out in front, you would get 2 times the log base 2 of 2, and again this is equal to 1, so this would be 2 times 1, or just 2. You could also though just evaluate this, right? What is log base 2 of 4? Well, that's just 2. 2 raised to the 2nd power would equal 4, so it's 2. So there's multiple ways for you to simplify this. And then log base 2 of x does not simplify any further, so this would be my final expression here. In number 9, if we expand this, this one's going to be a little bit trickier. We have a full quotient here, so we want to split up first the quotient. So write that as log base 9 of 3x squared minus log base 9 of y to the 5th. Okay, so from here, Now I'm going to start using more properties. When I look at this, I have a product, so I'm going to rewrite that as log base 9 of 3 plus log base 9 of x squared. And then I have this here, let's take that power and bring it out in front. So I have minus 5 times the log base 9 of y. Okay, now here, log base 9 of 3, we can evaluate this, since we have just both numbers here. 9 raised to what power equals 3? That would be 1/2. So 9 raised to the 1/2 power is 3, so this evaluates to just 1/2. And then here, I'm going to bring that 2 out in front and write that as 2 times the log base 9 of x. And then this cannot be simplified any further because I have this variable here, so this would be my final expression that has been expanded and then simplified. So the next type of problem that you're going to see is to condense and simplify a log expression. So you want to be careful and always make sure that you have the same exact base on your logs in order for you to condense your logs. Otherwise you can't condense and you can't use your rules that we talked about above. Okay, so we begin here by noticing that both have a base of 10, so we can combine these if we want. And I see that this is written as the sum of two separate logs with the same base. So I'm going to write that as one log with a base of 10. And because I'm condensing it, I'm going to write that as the product then of 2500 and 4, right? 2500 times 4. If I were to simplify this, I have the log of 10,000. And now I'm going to rewrite 10,000 as the log of 10 to the 4th, okay? Now I'm going to simplify this. Let's bring that 4 out in front. So we have 4 times the log base 10, or I'm sorry, log base 10 of 10. Now log base 10 of 10, this is going to simplify to just 1. So we have 4 times 1, which is just 4. In number 11, I see I have the difference of two logs with the exact same base. So I'm going to rewrite that as one log. So I have log base 4 of 48 over 3. So I turn that into a quotient. Now log base 4 of 48 over 3, it simplifies to log base 4 of 16. Now I can evaluate this. Just think about what you were doing, in the first couple days of the year, where you take 4 raised to some power is equal to 16. So I would get 2. Now let's say I didn't do it that way. Let's say I chose to rewrite log base 4 of 16 as log base 4 of 4 squared. Now I can recognize this as canceling, leaving me with just the 2, right? That's one way of doing it. Or I could also take that exponent, bring it out in front, and say that that's 2 times the log base 4 of 4. Now log base 4 of 4 clearly is 1. So now I have 2 times 1, which also gives me 2. So in each case here, I get the exact same number. There's a multitude of ways that you can use these properties. So don't feel like you have to be, stuck with one way of doing every problem. There's going to be lots of different ways, especially when you check your answers. Just like when we are doing exponents, there's lots of different ways to simplify those exponents. Now I'm going to write number 12 and bring this 8 out in front. So I'm going to write that as 8 times the log base 5 of 125. Now 125 is the same as 5 cubed, so this is 8 times the log base 5 of 5 cubed. And from here I notice that this just drops, right? This is 1, so I have 3. So this is 8 times a value of 3, which is going to give me 24. Now if I had done it a slightly different way, I could bring that 3 out in front of the log here and write that as 8 times 3 times the log base 5 of 5. This is going to simplify to 1, leaving me with 8 times 3, which gives me 24 also. Okay, now in problem 13, we actually have a variable here, but it doesn't make a difference with how we try to condense this. Both of these have the same exact base, so I can condense these. There's a sum here, so I'm going to write that now as the product. So I have log base 3 of 2 times 4x. So 2 times 4x. So this is log base 3 of 8x. This is as simplified as that expression would get. And I'm going to put that in parentheses so that I know that this product here is together. I'll let you try 14. Let's skip ahead to 15. So on 15, I see that I have the same log base, so that's good. I can condense this now. And I do see quotient too, because I have a subtraction, so there's a difference here. So I'm eventually going to write this as a quotient, but I don't want to start off with that yet, because I have this 4 out in front. I actually want to bring that back here with my argument, so I'm going to write that as log base 16 of x to the 4th. minus, do the same thing here with this 2. So this would be log base 16 of 3 squared. Now if you want, you can simplify that right away and just call that 9. So this would be log base 16 of 9. And then from here, now I can use the quotient and rewrite this as log base 16 of x to the 4th over 9. And this would be my final simplified expression here. Now I'd like you to try 16 through 18 on your own so that you can check those with a key to make sure that you understand how to use these log properties. We're going to finish up the lesson here with these extension questions. And basically, this is leading us into tomorrow's lesson. The whole point of understanding these log properties is so that you can eventually solve log equations. So in this first example, number 19 here, because I have the same log base, I can write this now as log base 4 of 3x equals 2. So I can find the product here. And because now it's simplified as one log, I can change this into an exponential equation. So I can convert this into an exponential equation by writing this as 4 squared equals 3x. So to solve for x here, I would simply divide by 3, and I end up with 16/3 equals x. So really that's the whole point of today's lesson, is to be able to do this tomorrow. So I'd like you to actually try 20 and 21 also, and I'm thinking I'm going to offer this as extra credit tomorrow in like a homework check. So I'll give these two exact questions and offer these as extra credit. So please try those, and nice job. I'll see you tomorrow.